Welcome back to the channel. Today we're going to go over my little lathe and the little mill. I got them both from Little Machine Shop, and I'm in the process of kind of upgrading the lathe or doing some modifications to make it better, and I'll show you what that is. It's kind of funny because I'm using the mill to fix the lathe, or I'm using their mill to fix their lathe. Anyway, I'll show you what the biggest problems I've had so far are so that you can think about maybe if you wanted to get these, because I've been using them for a lot of things, and I've been using that lathe for way more than it was ever intended to do. There was a huge pile of steel from how much I cut with it, and I was being aggressive. So it's not made for that. It did it, so that does speak a lot to it. But anyway, we'll get into it. It's not a lot, just some insight. So this is the Little Machine Shop. Model is 5100 high torque mini lathe, whatever. You can see the size of it. For what I do in here in the garage, the little things I need and like spacers and stuff, it's probably perfect for that. There's only one problem I've really had. It is sensitive to torque, so if it draws too many amps, it shuts itself off, and that's kind of annoying sometimes. But it's also probably saved it from breaking something. Because if I've had stuff go awry and start flopping around, it'll just shut it off, which is great. But sometimes you need it to apply more torque and it just shuts off. That part's annoying. But the biggest flaw is these. What stops this from flopping around? These set the tension, or the gap. I wouldn't say tension. These set the gap on the rails to pull it down into the V, and just to hold it down on this side. But see how thin this is? There's two set screws. Alright, so you set your set screws, you get your gap, you tighten the bolts. It's so thin that if you actually tighten the bolts, it just bends this around and locks down the table, or locks that down, so it doesn't work. If you leave them loose, they rattle loose. You could probably Loctite it, but then you've got to mess with that every time you want to adjust it, which shouldn't really happen that often. So what I've done is taken this front one, which I should have taken off, but I didn't. I've taken that one, put it in the mill, got rid of these set screws, and just shaved it off a little bit. Just put a step in it, and I'd go mill a little more, put it back on, check it, mill a little more, check it. I went a little too far, and it was too loose, and then I just touched this on the belt sander, just run it up and down a little bit, take a couple thousandths. So I've got this side set pretty good. So that was the only problem I had. When I was doing that machining, the bolts started rattling loose. And if you tighten them down, then the table's stuck. So that's a real pain in the ass. But we can fix it. We got a mill. So that's the only real problem I've had. This thing gets stuck a lot. The different tapers get stuck because the handles will back off because they're just threaded. They're not really keyed. They've just got a set screw. If it was keyed, it'd be much better. So you'll be trying to back it off to shove that out the end, and there's no good way to hit it or tap it. I've tried that, so that it'll get so tight and then the handle just starts spinning on the shaft. That's annoying. Same thing happens with these. They're not keyed, so if it's too much going this way, it'll just unthread itself. Other than that, it's been really good. And back to the mill. I haven't had any real problems with the mill. You've seen some of the stuff I've done with it. It's much larger than it was made for, and it's really been a trooper. Setting the gaps on this have been fine. They stay exactly where they need to be. If they're not set right and you're doing this by hand, you're pushing this way, and then when it comes around you're pulling and pushing, and it kind of walks, and that gets annoying. But if you have it set right, it's fine. So for this machine, I've had no problems at all. It's done exactly what it's supposed to do. So we're using this machine to fix that machine. All because I want to remake the pulley. I want to remake the spacer for the pulley for the supercharged 240. I went ahead and pulled that one off so I can show you. So instead of having set screws set this gap, this can get tightened up all the way and get all the way tight. And then I just shaved that to set the gap, and that's worked pretty good. But you just got to take little bits at a time so you don't overshoot it. I experimented with using like feeler gauges and thought about getting long feeler gauges and drilling holes and using that, but that was a pain in the butt too. I think this is the way to go. Of course, it really shouldn't wear out that quick. So I think this is the way to go. Although making adjustments now is going to be more difficult because you got to either shave this or shave this. But it's at least not going to rattle loose anymore. Because once I got done with my project, this whole thing was just flopping around. And it was very inconsistent. That's really it. I just had some people commented about how they were doing. And I'm sure because they're curious. Because I think they were like 1,300 bucks a pop, roughly. So for the dollar, it's pretty good. And I'm definitely glad I have them. So I just wanted to share what I've been dealing with them. Other than that, they've done everything they needed to do. I'm just trying to make it so it can do it a little better. So that whenever I want to take 5 thousandths, it's 5, not 8, 10, wherever it may land. So thank you for watching, and please like and subscribe.